everyone, welcome to the Cloud Concepts, Architecture, and Design for the CCSP course. This certification prep course will help you prepare for the Certified Cloud Security Professional Examination, the CCSP. In this course, we're going to cover the skills measured in the first domain of the CCSP exam outline. You will review the concepts and architectures of cloud implementation, but with a focus on how to secure cloud-based systems. This domain counts for about 17% of the total exam. This is the first of the 6 domains for the CCSP examination, and it sets a foundation that the other domains build upon. My name is Kevin Henry, and I'm an educator and security professional, and I've been developing and teaching information security courses for over 20 years, based on my own years of practical experience in the field. This course will address key topics related to the secure cloud deployments, securing data in the cloud, and evaluation of cloud service providers. This course is supported by several reference and exercise files. To download the exercise files, navigate to the Exercise Files tab and click on the Download button. In the exercise files, you'll find a helpful study guide that you can use to follow along during your certification prep for the CCSP exam. The study guide contains a glossary, a list of key points to remember, and sample questions. I'm happy to join you on your certification prep journey with the Cloud Concepts, Architecture, and Design for the CCSP course here at PaaS, and to improve your knowledge of cloud security. This is part of the Certified Cloud Security Professional Examination Preparation, and we're going to start out with the first domain, Cloud Concepts, Architecture, and Design for the CCSP. So let's start by looking at cloud concepts and architecture. This entire course is divided into 6 different areas according to the exam outline published by ISC². This first domain, Cloud Concepts, Architecture, and Design, is worth 17% on the examination. Cloud Data Security, 20%. Then we'll look at Domain 3, Cloud Platform and Infrastructure Security, 17%, and the same for Cloud Application Security. The areas of Cloud Security Operations is worth 16%, and the final Legal Risk and Compliance worth 13%. This course, Cloud Concepts, Architecture, and Design, is divided into 3 parts. We're first of all going to look at cloud concepts and architecture before we come back to visit the areas of principles of secure cloud computing. And finally, we'll finish this off with evaluating of cloud providers. In the area of cloud concepts and architecture, it helps maybe to take a look at where we've been and certainly, hopefully, a little bit of where we're going. The whole idea of the cloud is not really new. It's a marketing term brought out in the 1990s specifically to give mystery to this area of storing our data on somebody else's computer. Now, I know that might be a little bit simplistic, but in reality, that's kind of what we're doing. And that's why this course on cloud security is so important, because we're looking at an area that is very much beyond our direct control. It's a relationship quite often between 2 different parties. And that means that we need to understand what are the security implications of that relationship. But doing remote data hosting is something that many large companies and governments did all the way back in the 1960s and 70s. Now, however, we've greatly evolved and improved that to the area of things like orchestration and the flexibility. And of course, now it's open for everybody. Anybody can use the cloud, and most people do. They're backing up their phones, their pictures, and so on, and using cloud-based email services. Where's the future? Well, it would be always good to know, but this is a continuously evolving area. And we know that cloud deployments are most likely going to be an integral part of pretty much every business going into the future. So therefore, we should be aware of some of the security implications concerning this. If we look at the definition of cloud computing as provided by the International Organization for Standardization through their various ISOs, they say that it's a paradigm for enabling network access to a shared and elastic pool of shareable physical or virtual resources with self-provisioning and administration on demand. So the idea, of course, is that in many cases we've always used network access to a server in a server room, which is different from just having storage on our own computer. But the idea of being a shareable set of resources, both physical and virtual, provides many benefits, as we know, with the economies of scale and the ability to expand and even reduce the amount of equipment that I'm using and paying for as well. NIST defines cloud computing as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. For example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or server-provider interaction. The problem with these definitions is that there are many, many different deployments of the cloud. So NIST admits this in their statement. It is important to understand, however, that the term cloud computing encompasses a variety of systems and technologies, as well as service and deployment models and business models. A number of claims that are sometimes made about cloud computing, for example, that it scales or that it converts capital expenses to operational expenses, are only true for some kinds of cloud systems. So therefore, we see that the term cloud is very generic and actually refers to many different deployments. We also see this, that each vendor can kind of define cloud computing in their own way. So one of the things with this course we're going to try to do is look at things from a more generic type of perspective rather than how any one cloud provider actually provides service. Let's start looking at the various cloud deployment models from a very high overview perspective. NIST defines the cloud deployment models as composed of 5 essential characteristics, 3 service models, and 4 deployment models in the special publication 800-145. Those 5 essential characteristics of the cloud include on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. However, even NIST admits that many cloud deployments do not have all of these 5 essential characteristics. But this is what makes the cloud so flexible, usable, and practical for many organizations. You can expand and retract some of the resources you use as a self-service option. You only pay for what you use. You have access to a pool of resources rather than having to buy it yourself, for example. If we look at an overview, for example, of a public cloud implementation, we see a number of different elements to this. We see the cloud provider in the center with all of their various types of equipment that are available, servers, for example, for both compute and storage needs. And they are continuously improving those, replacing them, but it operates as a single unit to the cloud consumer. You have clients that initiate access wanting to subscribe to a cloud service. You then have all of those computers that are providing service through some type of a network, public clients accessing the cloud, and of course, new hardware going in and old hardware coming out. Then you have, of course, clients terminating access, leaving the cloud as well. If we went back to a traditional type of operation, we had then a consumer's facility with their users, and quite often they would have their own equipment. But now they are able to subscribe to a cloud-based service and not necessarily have to have that equipment on their own site or location. They have, of course, the need to provide proper security and isolation. And this is where very often we put up that security perimeter. That is where we can control access from our building to, say, the cloud service providers. So this is a high-level overview of initiating, terminating, maintaining access, the relationships between the various entities. We have three primary service models. Now, almost anything these days can be called as a service. Disaster recovery as a service, even ransomware as a service. But the three that are defined by NIST in 800-145 include software as a service, platform as a service, and infrastructure as a service. And we'll look at each of these a little bit more later on. However, we know that one of the important things with this is where is control? Who has responsibility? If we looked, for example, at a high level at software as a service, we can see that the cloud provider really has total control over the facility, the hardware, the operating system, the middleware, and they do administrative control over the application. The cloud consumer has no control over the building or equipment, and they only have a limited level of administrative control, say, for example, setting up user access levels, than for the application. We have four primary deployment models: the private cloud, on-premise or off-premise, community cloud, public cloud, and a combination of cloud providers in a hybrid cloud type of deployment. One of the important things we looked at a moment ago was the idea of a security perimeter. Having a defined area of responsibility that says what is within or inside my perimeter is that which I must maintain control over. Sometimes that was known as the trusted computing base. That which was outside of the perimeter was beyond my direct control. And I could try and control how data flowed from inside to outside through some type of a boundary controller, allowing certain activities in and certainly blocking others as well. Many organizations have looked at things like an on-site private cloud. That means that I take my own equipment, but I now use it as a type of cloud-based deployment, using some of the advantages of having things that are more shared resources. And we can see here in this case, in the case of a private cloud, that all of that equipment is inside the security perimeter of the organization. Now, we could also have a private cloud located at the facility of a cloud service provider. We can go to a CSP and we can then lease from them the space that our equipment runs on, perhaps in a protected cage at their facility. And so a private cloud really refers to a cloud for the use of one customer. And in this case, since this private cloud is located within the facility of the cloud consumer, then they control access all within their perimeter, but they may allow outside access as well through some type of approved and legitimate access path. When we look at the cloud, it's important to understand the roles of the various entities involved. Let's do a quick overview of what those main ones are. You have the cloud consumer or customer who's using cloud-based services. Now, I will point out that throughout this course and the certification by ISC², we often have a little bit of a bias towards the perspective of the cloud consumer. So very often when we look at things, we're looking at, if I am the cloud consumer, what do I need to do? And that's one thing to remember, that we still obviously have to consider the perspective of the cloud provider as well, but the natural default tends to be with the consumer. You have clients or users that are using cloud-based services. They could be employees of the cloud consumer. You have the actual cloud provider, the cloud service provider that is providing the facility for cloud-based services. And of course, you have the carriers, the networks that are enabling access even to remote locations. Some of the things we need to remember as we now go deeper into this course is that this term cloud computing is not just referring to one thing. It's sort of like using the term a car. Well, there's a big difference between obviously one type of car and another. A Chevrolet is not quite the same as a Maserati, for example, and yet they're both cars. So the term cloud computing may be used in many ways and is based on the way that cloud providers define, or let's say market, their services, and that cloud consumers use those services. For many people in IT, the movement towards the cloud is done a little bit apprehensively, especially for people in security who realize that going to the cloud, maybe we lose a bit of control over our direct security implementations. I do say sometimes, though, that organizations very often do securely poorly on their own, and therefore going to the cloud may actually be more secure than what they've been doing until now. However, if I don't do things well on my own, there's a very good chance I won't do it very well when it depends on a relationship with another organization as well. So those are the things that we have to consider. But an organization is going to go to the cloud whether or not we as security professionals want it. Therefore, we have to have ways to make it secure. We have to understand what are the risks associated with the cloud. So why would an organization choose to go to cloud computing? Well, beyond the fact that maybe the cloud service providers have very good salespeople, there are a number of other convincing arguments that can be made, such as capital cost control, the flexibility, access to skilled staff, and even environmental impact. If 15 companies move to cloud provider, that means that 15 companies can get rid of backup diesels and batteries and spare equipment. And so therefore, there can be quite an advantage, even environmentally as well. So the question comes, is the cloud secure? Or is the cloud more secure than what I have now? It's not an easy question because, of course, there's a wide variety of different cloud providers. And so therefore, we'd have to come back with that answer that means nothing, saying, well, it depends. It depends on the maturity of the organization, both of the cloud consumer and of the cloud service provider. And it also depends on what I'm paying for. What services are stipulated in the contract, because you can be fairly certain that if I have not put things into the contract, they won't end up being provided either. We also have to understand the legal and regulatory constraints and requirements of going to the cloud. Many organizations have even adopted a cloud-first strategy. We're going to go to the cloud unless there's a convincing reason not to. And that has been, in some cases, very good for governments and organizations. But we do have to consider things like legal jurisdiction. Where is my data stored? Where is it processed? Is it secure, for example? We need to understand that when we go to the cloud, as a cloud consumer, it's not that I get rid of my security responsibilities. No, I have to make sure that I'm still executing due diligence to protect my data, even though it's on somebody else's systems. We also have to look at the business case. Not all businesses are suited for the cloud. For example, you take something which is real-time sensors that require immediate reaction in case of, say, a safety issue. It could be the latency or delay of going to a cloud, or the unreliability of a network could mean a life-threatening situation. So therefore, some services just don't really lend themselves to a cloud type of environment. We also know that a person who works for a cloud service provider very often will have access to my data. If my data is highly sensitive, maybe that could be a problem. Maybe that data could be leaked, either intentionally or accidentally. So these are things we're going to look at in more detail as we get into this course as well. The idea of migrating to the cloud and moving to a cloud type of environment requires us to consider some important factors. What type of business we are, what are the legal requirements such as reliability, we could call that uptime, as well as reporting. Will I be able to report if there's any problem, issue? What is my level of insight into the cloud? As well as there are many different cloud options available. Which is the best for me? Go with one of the big companies, or maybe go with a small boutique firm that maybe can provide better customization and maybe even a better price than the large guys? We have to look at what type of delivery model works for us. And that, of course, could look at from anything on-site private to off-site private to community cloud. There's many different options, of course, even from software to platform as a service. Very often, one of the considerations for going to the cloud was economic. You'll save money. Well, that's not always the case. It could well be that I can change the way I pay, but in many cases we find that companies thought that they would save money by going to the cloud, and in the end found out they didn't really. But there are some very good advantages to the cloud. When I need to understand the business, I have to understand what type of business am I in. Competitive? Am I a service-oriented organization? And of course, where do I do business? Just locally, or do I do it nationally or even internationally? That can very much affect cloud services as well. Who are my customers, and what are the expectations of my customers for protecting their data? We also have to look at network requirements. Do I have a network capacity that will support my business in real-time operations? Or will maybe there be latency or unreliability there with networks? We have to look at how much data storage and processing do we need. Very often the cloud works well when my level of data storage or processing can vary, because I can change the number of services available. But that also comes at a price. Let's look at the building blocks that make up cloud implementations. Building the cloud is a combination of many different components working together. It's based, for example, on software, as in applications, as well as operating system and virtualization, for example. And this includes the applications that face the customer, as well as the applications used to operate the various operations, such as application program interfaces, drivers, and utilities, operating systems, and hypervisors. We, of course, rely a lot today on databases and the database management system that is provided by many of the cloud providers, the hardware that all of these systems run on, and that, of course, includes both compute and storage type of hardware systems. We rely a lot on networks for all of this to work, broad network access being one of the essential characteristics of the cloud. We can understand that the larger the attack surface, the more difficult it is to defend. And we can see that a cloud implementation has actually a fairly large attack surface. There are many different angles of attack that could be used just from a perspective of equipment and software, not even looking at things like physical security and people on top of all of this. A lot of the advantage that comes from a cloud implementation is getting all the pieces working well together. We can call that service orchestration. That is the arrangement, coordination, and management of all of these system components that are used by the cloud provider to provide services to the cloud consumer. We can see that we've divided this up into three major levels. The service layer, which provides access interfaces to the cloud consumer or user. And of course, that varies a little bit depending on the type of model, whether it's software, platform, or infrastructure as a service. We then have the whole idea of the cloud is really resource abstraction. The user does not need to know or even be aware of the type of hardware being used to support cloud services. They don't need to know the operating system because there's a level of abstraction there that really insulates and isolates the user, the cloud consumer, from the cloud service provider. And this resource abstraction and control layer is an important thing. We are no longer bound by the type of operating system or the piece of hardware we're connected to. Instead, we can be connected to many different pieces of hardware and easily move from using this piece of hardware to another, storing our data here to storing data somewhere else. And the cloud user doesn't really care or have any knowledge of where their data is being stored in that perspective. They may know the geographic location, but not necessarily the piece of hardware itself. And this allows the flexibility. This allows us to ensure that even if one piece of hardware fails, we can still have service through the other pieces. And of course, this resource abstraction is done by the cloud provider in order to manage the various system components. And they can do this through things like a hypervisor, for example, and the use of different virtual machines. Then we have the physical resource layer, the actual hardware that our system runs on, as well as the building it runs in, the facility. And this level includes things like the central processing units, networks, firewalls, storage, and heating, ventilation, and air conditioning. And this is a diagram used by NIST to try to give an overview of service orchestration. We use many different terms when we talk about cloud services, and these are things you'll see as we go through the course here. The idea of portability, vendor lock-in, cloud migration, cloud backup, hypervisor, virtual machines, containers, and all of these are different tools used in the implementation and operations of the cloud, and ones that we should certainly be familiar with that we will look at in more detail. So the building blocks of the cloud, the building that our systems are running in. And of course, that requires clean, reliable power, heating, ventilation, air conditioning, and of course, physical access controls. We have the hardware that our systems run on, as well as the operating systems, the hypervisor, network, application program interfaces, applications, and of course the most important part of all this, the whole reason for all of this is data. So we can process and store our data so that it can support business and legal requirements. Then we have the users. The users may be our employees, but also the users could be our customers, people we have no control over really. One of the things that's important with all of this is that we have a well-architected framework. In other words, we build all these components so that they work well together. The goal of a well-architected framework, as defined actually in this case by Amazon, is operational excellence, security, reliability, performance efficiency, and cost optimization. It is important that we can continue to use our cloud services and therefore sustainability is important as well. So this is how, for example, a good cloud implementation should work. It works operationally, securely, reliably, for example. The key points review. In many cases, it is only when a business uses a cloud access security broker or CASB that they may become aware of how many pieces of cloud services they're already using. Many businesses don't actually know how much of the cloud they already are using, and that of course means that they may not be as aware of some of the security implications of that as well. We know that migrating to the cloud is definitely an excellent option for many organizations, but not all. And things have to be carefully thought out. What are the risks? What are the business requirements before I do a mass migration to the cloud? Part of any security program is to ensure that roles and responsibilities have been assigned. If it's nobody's job, then often nobody does it. In the world of cloud computing, we have a few roles different from a normal business operation. But the assignment of a role creates accountability. It means a person is responsible to do certain tasks, and therefore they are accountable to make sure that they are done. We only have accountability when it's clearly defined whose job it is. Everyone assigned a role must understand the requirements, that what are they accountable or responsible for doing, and then they must execute their tasks in a responsible, thorough manner as well. This also means they have to have the skills to be able to execute their tasks as well. When it comes to cloud-based roles and responsibilities become more complex when there's a relationship between different parties. When it's all within one company, a senior manager can assign roles and those are in effect. But when we're dealing with a cloud service provider, there's a difference here where roles and responsibilities can be shared, and in fact they can be shared in different ways depending on the deployment model or the contract. The cloud service provider is responsible for providing cloud services to customers according to the contract terms under various deployments and service models. They purchase and maintain hardware, the building. They manage access control both physically and logically. They manage the network as well as, of course, the various building elements such as power, heating, ventilation, and air conditioning. They also manage the staffing of the cloud service provider staff, help desk, operations, and so on. The cloud consumer or cloud customer is an individual or an organization that consumes or uses cloud services. Now, they could also be a cloud provider. We have situations where one company can offer or sell software as a service to their customers, but they at the same time are purchasing platform as a service from another cloud provider. We see that, for example, in the area of things like streaming media. Very often you can purchase a streaming media that is a software as a service type of offering, but being hosted by then a large provider on platform as a service. Some cloud services are free. We've seen a lot of different offerings of email, for example, that's free for people to use. But in other cases, there is a contracted price. And even the free services quite often have a contracted price if you go above a certain storage level. The cloud carrier plays an important role because all of this requires stable, reliable networks. And the cloud carrier could be a telco, could be satellite. They are the ones providing some form of network access. And quite often we work with them to ensure we have redundancy so that if there was a cut cable, there would still be another alternate route for traffic to take. Now, that could be, say for example, if a fiber was cut. We could have another fiber that went a different direction, different path. Or it could be that we have a completely diverse type of routing, where instead of just having a redundant fiber, they might have a microwave or some type of satellite communications in case of a problem with the fiber or traditional telecommunications network. One of the things that's important here is to have sufficient bandwidth to be able to support all the needs of the various consumers of the cloud services. In some cases, it's best to work with a broker. A broker manages the relationship between the cloud consumer and the service provider. They might, first of all, try to determine which is the best cloud offering to use. They would then negotiate the contracts, and of course, they could represent several different cloud service providers. That's a little different from, of course, another reseller. A reseller is just someone who sells the services of a particular cloud service provider. One of the tools that's been useful for organizations is to use a CASB, a Cloud Access Security Broker. And the purpose of a CASB is to do exactly as it says, monitor cloud access, and therefore give us a glimpse into the security we have. So it monitors cloud usage and allows the IT department to be able to see what cloud services are currently being used. As we talked about earlier in this course, many organizations don't even know how many different cloud services they are using. The CASB can also help us then manage that relationship, the communications between the cloud service provider and the cloud consumer. One of the things that is then brought in through part of that administrative management is the management of access controls, that only the correct people are able to access those cloud services and hopefully only in the right way. One of the things that's been necessary for many organizations when they're considering a transition to the cloud is to have someone who is able to architect or plan the various types of implementations, and this is the cloud architect. They are a specialist that designs the cloud implementations and to ensure that the right cloud solution is chosen to meet business requirements. We also have cloud auditors and regulators. A cloud auditor provides independent assessment of cloud providers. And they are important, as we'll look at, especially in the third part of this course, where we'll look at the evaluation of cloud providers. We also have then the regulators that can review and make sure that things are being done correctly. There are a number of different standards we can use, such as STAR from the Cloud Security Alliance, the SSAE 18, though many organizations have already transitioned to the next version, the SSAE 20, and the international standard ISAE 3402. In the U.S. government, we have FISMA, which of course the Federal Information Security Management Act, though of course in some cases today with a revision to it called the Federal Information Security Modernization Act. One of the things that becomes more complex in a cloud relationship is where is the division of responsibilities. The one thing we should remember is that there are certain responsibilities that are always going to be those of the cloud customer. There are others that are always going to be the responsibility of the cloud provider. But there is a gray area in between that varies according to the type of service we're using. One of the things that is good to remember from a security perspective is that we see that data governance and data rights management, as well as client endpoints and account and access management, are always the responsibility of the cloud customer. The cloud provider always looks after the building, the physical host, physical network, and physical data center. But depending on whether or not we're using software as a service, platform as a service, or infrastructure as a service, the responsibilities could be those of the customer or of the cloud provider, or they could even be shared when we look at things such as, well, applications, network controls, and even we can say here, to identity and set up directory management. The key point to review. It's only possible to establish accountability and responsibility when roles are clearly defined. I've not gone into in depth here the differentiation between accountability and responsibility. Accountability is the person who's ultimately accountable to make sure something's done. Responsibility is the person who actually does the work. And each person may be, of course, responsible for certain tasks and accountable for what they did. Or we could have a situation where a manager delegates a responsibility to an employee, but the manager remains accountable for what that employee does. But that's part of our RACI models and something that we will look at in more detail later in the course. As we know, this whole area of, we could say here, roles, responsibilities, accountability becomes even more important, but also more complex when several different organizations are involved. Earlier in this course, we took a look at a quick overview of the essential characteristics of the cloud. Let's look at them in a little more detail. And for this, I'm going to rely on the NIST Special Publications 800, 145, and 146. Those are free documents, and they give us a good, fairly well recognized standard we can use. The first of those essential characteristics was broad network access. That means we have network-based connectivity between the cloud consumer and cloud service provider that is essential for this all to work. Now, the idea it was called the cloud in the early days was because whenever we drew network diagrams back in the 1990s, we always drew the internet as a cloud. And so the idea of cloud services was really just the marketing of saying we're going to use internet-based or internet types of connectivity in order to be able to communicate with then the data hosting organization. So the term cloud really referred to the internet. So we know that for many organizations today, we very much benefit from being able to use really inexpensive connectivity rather than leased lines, for example. One of the things about the internet is that it is fairly redundant, it's fairly robust. Certainly there have been some outages and so on, but usually they're only in a small region. But there's always still that risk of a single point of failure. The connection from the last point of the telecom provider's building to our office. It's sometimes called the last mile or the subscriber loop. The idea is that that may be a single point of failure. So a large cloud service provider will usually make sure they at least have redundant connectivity. But even that can be difficult to maintain. Things get moved around, and there's been cases where companies believe they had redundant fibers, only to find that the fibers, even though they were from two different telecom providers, were actually in the same cable in the same trench. The other thing is to make sure we have enough capacity. We certainly have seen a great increase in the amount of data we transfer, and we have to ensure that the cloud carrier will be able to support peak demands of traffic as well. The other challenge we have is that we have many different types of endpoint devices, well, even different types of mobile phones. Everything from, of course, different operating systems, but that's not all. We have many devices connecting to the cloud now from all sorts of Internet of Things devices. And each of those can have its own proprietary languages, its own proprietary needs. And so when we look at the cloud carrier and broad network access, we have to be able to ensure we can support all those various types of endpoint devices as well. The idea of on-demand self-service is the ability of the cloud consumer to change their, should we say, contracted usage of the cloud without going through all kinds of administrative negotiations and contracts. The idea now is that the cloud consumer can increase or decrease their requirements for compute, processing, storage, and network services automatically. And we all know that many of us have done this. You can easily add something on and you don't have to, negotiate with a salesperson or whatever, or in any way interact with cloud provider staff. And that's much better than the old mainframe days where, we had to negotiate for months to get a few more MIPS, or millions of instructions per second, or a new logical partition and so on. One of the greatest advantages, of course, to the cloud is resource pooling. The fact that we used the example before, we can have 15 companies that each had their own data center. Now they use one data center. That gets rid of 15 air conditioning units, diesel generators, backup batteries, 15 companies all managing their own physical access, each one having their own spare parts. No, we now share one facility in a multi-tenant model. Now this, of course, brings in a concern. My data is in the same building as maybe my competitor's data. But the advantage is we have pooled resources. Instead of me needing to have enough spare capacity to meet peak needs, I am able to access a pool of spare capacity that I can use when I need and I release when I don't need. So this, of course, includes everything from equipment, such as memory and processing. But the other thing that many companies struggle with today, of course, is staff. Where do we find knowledgeable staff to support all of our IT needs? Well, if I can use a cloud provider, they have staff there that is dealing with different types of IT support for many companies. They have experience. And of course, we have economies there of scale and so on. We also have, of course, the network where we're able to use a shared network. But this is, again, where we have to look at enough capacity and so on. We share memory. The problem with that is I want to make sure that there's no residual data left on a piece of equipment that could then be accessed improperly by somebody else. We can, of course, have a private type of cloud off-site. Of course, on-site we can have one, but when we deal with private off-site, we're renting some floor space from a large cloud service provider, and we have our own equipment in there, maybe in a cage of some type, and the cloud provider provides all of the physical facility, network power, heating, ventilation, air conditioning, physical access, but we don't have resource pooling. In this case, the hardware, the memory, and so on that we have purchased and installed at the cloud service provider's premises is for us only, and we don't have easy access always to additional resources. So the idea here is we still have pooling, but only the infrastructure, the building level, we could say. Now, they, of course, do have the advantage that they can provide staff and support for us. Another of the advantages, of course, is rapid elasticity. Rapid elasticity refers to the ability of the consumer to be able to access or provision, but also then to release service capabilities automatically, part of this self-service, according to demand. So the idea here is that an organization is able to acquire greater bandwidth processing and storage capabilities very easily, but also release them when they don't need them. So we can meet peak needs at certain times of the year and not pay for those pieces of equipment to the times we're not using them. We also have then the ability to do things like cloud bursting. Maybe I have a private cloud, but I realize I have a peak demand that I need additional resources. So I would be able to actually migrate some of my services temporarily onto a public cloud type of environment. Measured service is important. We pay for what we use. That means we don't pay for what we don't use, but it also means that quickly we can end up paying for a lot of stuff we're using that maybe we shouldn't be. So the idea here of billing and monitoring is that I don't have the initial capital expense of some of the equipment, but I'm able to only pay for the resources that I'm actually using at any one time. Of course, this doesn't apply to a private cloud because that's my equipment that I've purchased. The one advantage sometimes of that, though, is that if I'm working with a large cloud service provider, they're probably getting a far better price on a lot of their hardware than I am. And it could be we're even using them to provision equipment for our private cloud if it's an off-premise. Again, there's so many different types of deployments. The one thing that you'll see later on that becomes a factor in this is what we call VM sprawl. And this is where, as an organization, we spin up a virtual machine. When we spin that up, a certain number of resources are allocated to us for our use of that virtual machine, and we start paying for those. Let's say that a few moments later we don't need that and the technician walks away, and they leave that still as dedicated resources that we pay for. And this is a very common problem that companies have. It's called VM sprawl. We end up, and I've seen cases of hundreds of virtual machines that have never been used or haven't been used in years, that company is paying for because they're not cleaning up and releasing those as well. So that's one of the disadvantages of measured service. It's too easy to use too many resources without realizing what we're using and what it's costing us. When we look at the various cloud deployments, we've seen, for example, and discussed a little bit about a private cloud, which quite simply is a cloud or a set of IT infrastructure which is provisioned for the exclusive use of one organization. And many companies have done this. Yes, they're using cloud-based services, but they are the only tenant. It's not a multi-tenant environment. This could either be in their own facility, their own server room, or off-premise, as we've discussed as well. In many cases, the private cloud could be owned by the organization itself, or it could actually be owned, managed, and operated by a third party, where the third party actually does all of the support work to ensure that this operates correctly. The organization that is the cloud consumer then doesn't have to worry about their IT. They've outsourced all of that. When we look at an outsourced private cloud scenario, for example, we can see on the right-hand column here the customer's facility, where they have their own users and within their trusted computing base, their security perimeter, and they manage things within there, the things like the endpoints and user access levels. But within the facility of the cloud provider is a separated area which is very often physically isolated from the other parts of the cloud service provider's service offerings. And it becomes a separate domain within that cloud provider's facility. And it is there for the exclusive use of that consumer organization with its own perimeters, its own access controls, and so on. We also, of course, have the most common, the public cloud, something that almost everybody uses today, where we have a cloud infrastructure which is provisioned for open use by the general public, email services, and so on. This exists on a premises of the cloud provider, and in fact, in most cases, the cloud consumer has no idea where their data is actually being kept. They don't know where their email physically is located, or all of those pictures that were backed up off of their phone, for example. We also, of course, have where several organizations work together. This is a community cloud, and this has been done by universities, it's been done by hospitals, it's been done by government. The idea is that you have a cloud infrastructure which is provisioned, but only for a select group of organizations, maybe a specific community of consumers that very often have the same types of requirements. 2 or 3 universities or 2 or 3 hospitals, for example, go together, and instead of each having their own separate data center, they have one shared data center because all 3 hospitals really have the same regulatory needs, the same types of policies, and so on. So therefore, community cloud can operate for one of the universities. Maybe it's even an on-site private cloud, but for the other 2 universities or other 2 hospitals, it's an off-site private cloud. But it's a community. The 3 of them work together, and of course there are the advantages of the resource pooling and economies of scale and so on. Now, it could well be that I gave you the example that of the 3 hospitals, one of them hosts the data center, but we also see other cases where that community was hosted by a third-party cloud service provider as well. And of course, this could be either on the premises of one of the universities or hospitals or off-premise altogether. The idea of an outsourced community cloud, we see that we have a number of different organizations that are similar on the right-hand side here. Community organizations consuming cloud resources. Each one has its own security perimeter, its own trusted area that it communicates through some type of access controls to the community cloud, which in this case we're showing hosted as a cloud provider's facility that really operates, as we said, almost like a private cloud, except for the fact that it's for, say, 3 companies in this case, but within that cloud provider's facility. We also have the hybrid, which quite simply means we're not satisfied with any one of these, we use a combination. So a hybrid cloud is a composition of 2 or more distinct cloud infrastructures that operate as separate entities, but are bound together by standardized or proprietary technology. So this could be for the sake of business continuity. It could be, of course, that we have a couple of different infrastructures that operate and cooperate. We could say that even though they're separate entities, it's seamless often to the cloud consumer because the data can pass back and forth between them without any restrictions. So this allows what we called before cloud bursting, where I can easily move some of my processing off to another facility, and is what we would therefore call data portability. We see here in a hybrid where we could have a combination of almost any of these. A combination of an on-site private cloud, an outsourced private cloud, an on-site community cloud, an outsourced community cloud, or the public cloud. And so a hybrid is, as we said, 2 or more of these that work together. Let's look a little more in depth at the various cloud service models. Software as a service is something we're all really very familiar with, where, for example, a consumer uses applications provided on and running on the cloud service provider's cloud infrastructure. The cloud service provider manages the application, say email or some type of, say, streaming for some type of media, and the consumer accesses the application through a thin client, say a browser, or some type of application program interface. The consumer may actually manage access for their users. If I have an account to watch some type of streaming, say for example shows on television, I may be able to share that or have a family joint account for access. In software as a service, we see here that The areas that are the responsibility of then the software as a service cloud service provider is then the actual presentation. How would they then interface with the user, and the platform used for that, the application program interfaces to access things like their databases underneath the application, and of course they manage the data, metadata, and content that is available. We can see then that this runs on top of a platform as a service, which in fact also then runs on top of infrastructure as a service. The division of responsibilities in software as a service is, as we looked at earlier in this course, the cloud provider manages the application, patching it, and so on, such as mail. They then, of course, also have total control and ownership of the middleware, operating system, hardware, and even the facility. The cloud consumer really has no control over where their data is stored or processed, and very limited admin control, say, for example, just things like user access. When we look at platform as a service, this is where the consumer can deploy customer-created or acquired applications on the cloud service provider's cloud infrastructure. The cloud service provider provides libraries, services, tools, languages. So say, for example, I bought an application that I want to use, a finance application. I could go to a cloud service provider and say I'd like to run my application on your platform, and the cloud service provider would then provide the infrastructure for my application to run on, the servers and very often even databases and so on. And the cloud service provider manages that underlying infrastructure while the consumer has to manage their application, which would include things like patching their application and so on. If we look at this, now we see that the responsibility of the cloud service provider is the element of infrastructure as a service, but on top of that, the integration of middleware necessary for the application that the consumer has purchased then to run on. In this case, the cloud service provider has no control over the application. It's being managed by the consumer. They do the patching. They still have admin control over middleware and total control over the physical facility. The cloud consumer has real control then over the application, the installation, patching, and so on, access controls, and they also then have to manage their interfaces between their program and the underlying infrastructure. In infrastructure as a service, the cloud service provider provides the building, the underlying infrastructure, but the consumer manages operating systems, storage, applications, and perhaps even some network components at times. And in this case, of course, we said we could have a off-site private cloud be a very good example of this. So the cloud service provider manages the facilities, hardware. They manage the interface down to the hardware through some type of abstraction. And they deal with, of course, network connectivity, and then there are the APIs, which become the interface between the consumer and the cloud service provider's areas. In this case, the cloud service provider has total control over hardware. They have admin control over the hypervisor, but we can see here the cloud consumer has to be able to interface with that as well. And total control of the application middleware and guest operating system has now passed from the cloud provider to the cloud consumer. Let's wrap up this first part of the Concepts, Architecture, and Design course for the CCSP with a few of the other things we need to consider for the cloud. For example, the cloud is a shared facility in most cases, and that means we have to make sure we have things like interoperability, but also portability. We can move to different cloud providers, we can move our data around, and hopefully in a seamless manner. That means also we have reversibility to be able to go back when necessary, but also good governance, something we'll look at in Module 4 when we're taking a look at evaluating cloud service providers. We need to make sure we have the levels of availability to support our business needs. That means resilience in case of some type of network or hardware failure. We certainly have to consider security in the way we deploy the cloud, and that of course includes the protection of privacy and personally identifiable information. We should also be able to assess and audit our cloud services to make sure that we're getting what we're paying for, and as a cloud service provider, that I'm providing what is termed in the contract. The cloud, of course, has to interface with many different technologies today. And of course, a lot of these are computationally intensive tasks. Things we used to talk about grid computing to solve very large mathematical challenges, for example. And a lot of these require a large storage and data analysis processing capability, and the cloud has really helped with that. We mentioned grid computing was used to try to solve the human genome and DNA, and that was done through a lot of independent computers. But now, we quite often, using a cloud service, can bring that all into one location. We also see this has been used in some of the blockchain calculations and cryptocurrencies, and of course in the development of artificial intelligence. And we see how we're able to very much improve the way we can do data analysis, and from that extract out the metadata and knowledge from the data through vast amounts of data processing. This, of course, helps us to improve on machine learning, so our systems become more adaptive to changing situations and more responsive as well. When we look at cloud-enabled systems, we see a lot has moved now from just large central data centers out to things like edge computing. We have the integration of many things besides just desktops and laptops and the whole Internet of Things. And this, of course, allows many of these systems to be able to share data in a way that is far less expensive and, in many cases, far more effective than it was ever possible before. We also have seen that a lot of new development has been enhanced through the use of cloud services. For example, I can create new applications and collaborative work teams using things like DevOps or development security operations as well. We've seen the talk about quantum computing and the ability to be able to integrate faster and faster processes into our systems as well. In summary, in this module, the first module here of this course, we've looked at some of the core principles of cloud